Very good afternoon to all of you. I think as my colleague pointed out, I think the Indian Arctic policy has driven from strong science drivers. So you all know that how India is far away from Arctic, but what is the science drivers? So I will briefly explain to you what are the science drivers we are looking at from the Arctic angle. As you all know that in the Earth system, we have 5 spheres: atmosphere, hydrosphere, cryosphere, geosphere, and biosphere. But the most importantly, the cryosphere component, we look at holistically in all 3 poles: Antarctic, Arctic, and Himalaya. As you all know that when the climate change is happening, the first one to respond is the cryosphere. Hence, we are looking at it deeply. When you talk about climate change, or maybe when you talk about Arctic change, there are 4 important things which changes. One is a climate change, and the second one is resources in terms of living and ecosystem, and the third one is non-living resources, actually basically oil and gas or minerals, and the fourth one may be the northern ship routing. Of course, I will be more focused on climate change and its impact on the Indian contents. When you talk about evidence of impact of Arctic warming, the first one is the large impacts on Arctic ecosystem and the changes in the balance of physical process and the strong feedbacks, and also the impact of lower latitude in terms of climate and weather. So you all know that all the 3 important things: surface temperature warming, decrease in sea ice extent, and sea level rise. These are the 3 important drivers of the climate change under this warming world. So all these things are happening in the Arctic. When you talk about climate change and what is the polar connections, there are many variables. One is a sea ice decline. So when you have a sea ice decline, there is an extreme rainfall many places. I will come back to a little later. And the polar vortex is changing. Whenever the polar vortex is changing its speed, and what is happening in India and other places, and the glacier and ice shelf melting, the long-term sea level rise, and permafrost degradation, of course, the emission of methane and other greenhouse gases, and of course, the cyclone and other extremes continues to increase. So when you talk about why India in the Arctic science drivers, this is the main 3 things. One is the teleconnection, of course, between the Arctic and the Asian monsoon, and different time scale, intra-seasonal, within the month or 2, within the season, as well as the interannual and the decadal and much longer time scale. What is the teleconnection exists? And the second one is you all know that the air temperature is warmer, or the increasing trend is higher in the Arctic region, but you all know that the Indian Ocean, where we are, is the highest warming trend in the ocean. So that's why there is a link between the Indian Ocean and the Arctic. And also the short term, when you are talking about in the monthly scale, we have an atmospheric bridge, that is atmospheric connectivity, whereas in the long term ocean tunnel, it is taking in the year and beyond, it is an ocean tunnel, which is connected to the Asian continent and the Arctic. Of course, we are trying to reveal the past history from all 3 poles, from Arctic, Antarctic, and the Himalaya. So the first one I will talk about what is the impact of Arctic oscillation in winter monsoons. So just quickly, when we are talking about winter time, whenever there is an Arctic oscillation in a positive phase, we will have more precipitation in northern India. You can see that, for example, in 2015, in March rainfall, usually in March we don't have rainfall. But whenever the Arctic is a positive phase, we have a huge rainfall in the March in the Indian continent, which is, though rainfall is good, but in the March it is not good for many of the crops and other things. So there is an Arctic oscillation and winter monsoon connectivity. Number 2, in the Indian Ocean. When you have actually MJO is the MaddenJulian Oscillation. It is basically a convective activity in the equatorial Indian Ocean. Whenever the convective activity is happening in the Indian Ocean, and there is within a month's time scale, you will have a lot of heat transported to the Arctic, and you will have a melting in the Arctic. So the top one shows how much contribution from this MJO is melting the heat in the Arctic. Roughly about 10 to 20% of the heat is mainly from the Indian Ocean convective activity. The Arctic is warm, sea ice is melting. So there is a connectivity between Indian Ocean convection versus Arctic sea ice. And the third one is the pathway linking between monsoon heating. Basically, whenever there is a extreme rainfall, now for example, the Pakistan or in the northwest India, whenever there is a extreme rainfall is happening, lot of heat is transported to the, from the atmosphere all the way to the Arctic. Again, there is a heating is transported to the Arctic, and it is a melting is happening because of the extreme rainfall. So whenever there is a extreme rainfall, you can get within 16 or 2 weeks to 3 weeks, you can get the heating effect in the Arctic, so that melting happens. And the fourth connectivity, if you can see that Asian monsoon. Of course, whenever there is an Asian monsoon, there is a 4 months we get almost 1 meter rainfall. During that time, the convective activity or the precipitation has produced lot of latent heat, and that latent heat is all the way transported in the polar circumference region, and it is making a dipole in the Arctic. That means one region you will have a more ice melt, in another region there is a opposite behavior will happen. And up to now you are talking about the connection between the tropics and the Arctic. Whatever is happening in the tropical region, there is an impact on the Arctic. Now some cases you can also see that reverse way. In the long term trend, you can see whenever there is an Arctic sea ice loss, and we get, especially in the late August, September, we have a strong extreme event is happening. Especially in the recent time scale, you get the extreme rainfall events in India, it is increasing. As I mentioned, it is average, the rainfall is 1 meter around, but earlier also 1 meter and now also 1 meter, but now the extremes are, that means more rainfall, it is a flooding is happening more frequently, and then the earlier things. So that is more important because of, that is mainly because of the Arctic sea ice loss. So also if you talk about interannual time scales, whenever the Greenland sea ice decreases, we have there is a Pacific warming is happening because of the El Nino changes and other things, and then we have a direct link between Greenland sea ice and the Indian monsoon rainfall. So there is a connection between Asian monsoon and Arctic sea level in the interannual time scales. So coming back to this, although there are teleconnections exist between atmosphere and the ocean also play a significant role, because whatever the sea ice melt in the long term, that ice sheet melt has contribute to sea level, and the Indian Ocean, you know that unlike other ocean, Indian Ocean is blocked one, and you expect a large sea level rise in the Indian Ocean unlike other ocean. So hence Arctic research is very important. So in that connection, we started Indian Arctic program. Mainly the thrust areas are various kinds of long-term monitoring, and also we have done a lot of science in that connection, and also Arctic science management now we are going on doing for the last few years. And then what is our goal for the near future is the improvement of our understanding with all the countries, and also we need to improve our observation capability as well as modeling for forecasting in the future. And finally, I would like to have strong collaboration and networking in both within the Arctic nations as well as in entire globe. Thank you very much for your attention.